Right, so we just started the recording. So first of all, thank you very much for to all of you for attending the workshop. So it's an immense pleasure to that we myself and my colleagues organize this workshop. So I hope this will help somehow PhD students and early career colleagues to get some feedback, positive feedback that can help the paper, and also maybe connecting, creating some connection and network within the academia and maybe the business, if some colleagues from business are attending this. So a big thank you to the speakers who submitted their papers and for their willingness to share the knowledge and present their paper here. So I'm going to start with the first speaker. So I'm sharing the first time. My name is Abdurrahim Taimuti from Liverpool. So I'll be sharing the first session. So our first speaker is Luca Neri from Bologna University, and will present invalid proxies and volatility changes. So you have 20 minutes, including the questions. So colleagues can write their question if they prefer in the chat, and we can read it on their behalf, or they will be unmuted to ask the question. Thank you.
If I may add, actually, we can even give feedback by email or getting in touch with speakers, because there's quite a lot of people today. So we don't need to limit it to the few minutes we have together, especially if presenters want to talk all the way to the end of their time.
Thank you.
Sorry.
Yeah.
So thank you, Abderrahim. Thank you for the organizer for including my paper in the program. This is a work in progress paper project together with Giovanni Angelini and Luca Fanelli at University of Bologna. And we are basically investigating the role of invalid proxies for identification together with volatility changes. And I hope this will become clear in a second. During the talk, I want to go through the introduction, and then just to give you a bit of flavor, and then quickly jump into the framework and the identification theory. And then I have two brief sections that I hope I can go through, which are a small empirical illustration and then Monte Carlo studies. To start with the introduction, this is an introduction slide, so take it as it is. External instruments, this is the topic of the talk, are a popular and powerful tool for identifying the effects of policies in macroeconomics. What I have in mind is, for example, proxy SVAR and local projection with external instruments. So the identification conditions in this case require that the external instruments are both relevant and exogenous, whereby relevant I mean that the instruments are correlated with the target shock, where let me introduce some notation already, where Z is the external instrument, epsilon1 is the target shock, and phi is the relevance parameter, which is different from 0, could be a scalar or a matrix. And then the instruments are called exogenous if are uncorrelated with the other non-target shock. And by non-target shock, with the non-target shock, I use, to denote the non-target shocks, I use epsilon2. These could be vectors. So let me just give you a brief definition of what we mean by invalid instruments. We mean instruments for which condition 2, either condition 2 or both 1 and 2 fail, where 1 was the relevance condition and 2 is the exogeneity condition. Failure of the relevant, however, we're going to talk also more broadly about the case of failure of the only of condition 1, the relevance parameter. So failure of the relevance condition causes undercoverage of standard confidence sets. And for this, we need robust methods for inference. And there is a notable example, a recent example of Monteiro, Lestock, and Watson in Journal of Econometrics, where they explain how to address this issue. Failure of the exogeneity condition, however, generally leads to inconsistent estimators. You know, in a time series setting, you may think of adding lags as instruments, and this could actually favor exogeneity, but this is also as a cost in the sense that it is detrimental for relevance, and therefore your instruments get weaker. We are now we are talking about introducing the volatility changes into our context. The volatility changes are as opposed to the proxy SVAR, which is partially identified, allow for full identification of the whole system. And by volatility changes, I mean, for example, radical changes of policies. For example, you know, the inflation moving to the inflation targeting in the Volcker era, or maybe, you know, long periods of lower volatility. For example, you know, great moderation, the period of great moderation. So these are like, you know, the regimes that I'm going to talk about. And the main question is, can we use instruments together with the knowledge about these macroeconomic regimes? And the answer is yes. There is a paper already published in QE by Schlack and co-authors, which are actually combining external instruments and volatility changes for identification in the context of monetary policy. There is also another recent working paper of Martin Bruns and Lutkepol, which, however, they don't discuss identification. So in the paper, we are really after on answering the question, what is the role of invalid instruments? So this is for example, just, you know, a brief illustration of a 3-equation VAR with a finite lag, and this is the innovations of tax revenues, government spending, and GDP. These are all in real and per capita terms. You know, we placed a break on the third quarter of 1984, and you can see basically, and this is just right after the implementation of the inflation targeting of the Volcker administration, and you can clearly distinguish a lower volatility regime with respect to our higher volatility regimes. Maybe here it's a little bit more obvious compared to this one, for example. So this is what I mean by regimes. So in the paper, we combine features of the two identification schemes, volatility changes and external instrumental variables, in order to sharpen inference on structural parameter of interest. And in particular, in this context, we allow for regime-dependent impulse responses. So what we find is that in the presence of informative volatility changes, which will become clear what I mean by informative volatility changes later in the paper, in the presentation, but it has to do with a rank condition. Proxies used together with volatility changes in SVAR settings, they provide full identification. And plus, so even if the instruments are not exogenous, sorry, and we are able to retain standard inference with a moving block bootstrap, even when the instruments are weak. So we leverage the information which is included in either weak and or instruments which are not exogenous for sure labeling criterion, but also in some cases in order to shrink the confidence intervals of our impulse responses. Methodologically, we derive novel, necessary, and sufficient conditions for local identification in the general case of volatility changes and regime-dependent impulse response. And then we have a small empirical application, which we just estimate a change in the correlation of a tax narrative with identified tax shock. But this is just a preliminary work. So we connect to the literature of identification through changes in volatility, which is divided between regime invariant impulse responses and regime dependent impulse responses. We also connect to the literature identification and inference with instrumental variables. And lately, and we hope this is still work in progress, we want to connect to the econometric analysis of fiscal multipliers, which will be like a stone in the sea. Our framework, in order to jump into our framework, just as brief introduction slide.
Luca, just if you go to the you know, so I'm wondering whether there is a missing paper that maybe you should look at it. Was presented, in fact, in our virtual seminars.
This one, no?
Is it? I think by Silvia Gonzalez. Maybe it's worth. I think she presented something on impulse response function with regimes. So maybe, you know, just for
yes.
Yeah, you will find it in the list of our seminars.
Yes, thank you.
Thank you.
So we propose an extension to the stability restriction frameworks, actually, of Magnus and Mavroedi, such that we incorporate variance shift with macroeconomic regimes. We identify the impulse responses through those regime changes, but we also allow for the presence of external instruments which may be weak or contaminated. And by contaminated, we mean that we fail the instrument fails the exogeneity condition. We work with the SVARs, in particular finite lag SVARs, and this is really standard. And we have a relation between the reduced form and the structural shock, the reduced form innovation and the structural shocks through this matrix H. Then with our approach, we will let H and possibly pi also to shift at a known break date. And we call that regime changes. So we define a break date by using this notation, but we assume it's a known break date. And therefore, we have that the reduced form innovations are defined like H1 times epsilon before the break, and H2 times the structural shocks after the break. We introduced a measurement equation for an observed R-dimensional instrument, where phi's are the relevance parameters with the structural shock, the target structural shock, and omega, lowercase omega, is instead a measurement error, which is IID 01. Then we can basically stack together U and Z, and we have something like this formulation for regime 1 and this formulation for regime 2, where, basically the H1 is the matrices, the elements of this 2. So then a list of assumptions are in order, but I will just go briefly through them. So we have a compact augmented model, which is a compact constrained structural vector autoregression, where we stack Y and Z and U and Z all together, and we call eta the vector of reduced form innovation. We have a time-varying volatility covariance matrix of the etas, and it's like a step. It follows a step function with break non-break at times TB. So we have first volatility the first regime, and volatility plus volatility the second regime times the indicator functions, and possibly we let pi also to follow a similar process. The Y is a covariance stationary process, and we are really flexible. We can be flexible about the innovations. The relevant assumptions are, however, that we have the two separate volatility regimes, but also that these two volatility regimes are different from one another. And then we can stack the measurement error together with the structural shock, and we have a new structural form relation, which is basically relating etas to this xi, so with a new matrix G1. Okay, and it differs from G2 in the second regime. So in order to implement a stability restriction, we model the increments from G1 in G2. So G2, we define it as G1 plus the increments in G1. And then we have this is the equations where we model the restrictions, where gamma is the actual structural parameters or the non-zero parameters of G1, whereas delta is containing the non-zero parameters of delta G1. S G1 and S delta G1 are two selection matrices, and the parameters gamma and delta have dimension G and D respectively. We collect them in a vector of structural parameters of interest. It would be also a subset of those, which we call theta. Then the G will look like, G1 will look like H1 omega 1 with a new element. We'll add this new element inside here, R,
so
and G2 is
around 4 minutes, something like that, 4 or 5
Okay.
minutes. Yeah, thank you.
Okay, so what we do is basically we let this 0 to be violated such that the instruments can also be not exogenous, and then we have therefore additional notation where gamma 1 is the outer product of G1 and gamma 2 is the outer product of G2, and then we have basically these identifying moment conditions where we relate the variance covariance matrix of the reduced form to the structural form. You combining these two information, we have a Jacobian matrix, and we have the main result of the paper, which is the identification. Given the assumptions above, the necessary and sufficient condition for the local identification of theta naught are that the rank of the Jacobian matrix is given by is of rank, the Jacobian matrix is of rank G plus D, which is the number of structural parameters. And we also have a necessary order condition such that the number of equations are more than the number of parameters. Interesting, this is the main point, that the corollary is of the proposition is that the necessary and sufficient rank condition on J theta holds without any condition or R phi. Therefore, we can allow our instruments, this is what it says, that we can allow our instruments to be weak or violate the exogeneity condition. We have another proposition regarding the estimator or minimum distance estimator, which is asymptotically normal given the rank condition. And we can test the over-identifying restrictions, the stability restrictions of delta G1 by means of a J statistic, which we call J statistic with a break, which follows a chi-square with degrees of freedom, number equation minus number of parameters. And this is peculiar to the case with break. So in the case, I will show you briefly the empirical application where we basically take a 3-equation model of fiscal policies, and we use a standard data set of Mertens and Raun, combine it with the tax narrative and government spending narrative. What we want to do is basically we want to estimate the relevance parameter and see whether it change after a break date, which we place on the third quarter of 1984, right after the Volcker administration. This is the instrument, how it looks for Morten, the tax instrument for the tax shock, sorry. And this is the instrument for the government spending shock. Basically, we let the model as unrestricted as possible with some stability restriction. This is the picture that I showed you before, and we have these impulse responses, which in some cases have a shorter length of the impulse responses. We can basically do inference, and I can tell you here that we show that we see that the relevance parameter is basically becoming relevant only in the second quarter. And this is also agreeing with the correlation coefficients that we find between the instruments and the identified tax shocks. In the Monte Carlo simulation, we just check the fitting, we check the power size of identified restrictions, and we will include a coverage, the coverage probability of our confidence intervals. It's a bivariate system. We can see basically that in compared to the case where we don't use instruments together with the regime changes, we have, so this is our approach and this is the competitors. If it's greater than 1, it's worse than what we do in terms of relative mean square error. And here you can see that the exogeneity gets worse and goes. So the more you go here, the more exogenate, there is a greater, the exogeneity condition is less likely to, it doesn't hold, it holds less, basically. And what we see is that we do better by compared to increase of the, or our approach does better, also increasing the correlation between the instruments and the non-target shock. I think I will skip now the Dover identifier restriction test and the power to show the power and size, but basically it's Monte Carlo, everything works and it looks nice. Also this one, I'm sorry, I didn't go through real quickly. When identification, just conclude, when identification is achieved through changes in volatility, external instruments can be used also when invalid. They are useful for labeling and shrinking the confidence intervals. We have a lot of Monte Carlo, and we are going to work on the empirical part more in the future. We have some to-dos, and I'm happy to take some questions, maybe via email since the winter time. Thanks.
Thank you very much. Thank you very much, Luca. It's a really very good paper. So I think so we're gonna move to the next one. But remember, we have a break where we can please write down your question, because we have to, make sure that everyone gets the time. And you can ask your question during the break if you have one for Luca. So I'm gonna stop the recording here.